Welcome to Study Loop.
We're told our freezer has a coefficient of performance of 2.4. The freezer is to convert 1.8 kilograms of water at 25 C to 1.8 kilograms of ice at minus 5 C in 1 hour. What amount of heat must be removed from the water to convert it to ice? Okay, so we have our givens, and we know the latent heat of fusion for changing water into ice is 3.34 times 10 to the 5th joules per kilogram. So we can figure out what the change in internal energy of the material is, of the water, of the fluid. So it is the amount of energy needed to take the liquid water to solid water, so the water to ice. So that's the mass of the water, which is also the mass of the ice, times the latent heat of fusion. And then we also have minus the mass of the water times the heat capacity of water times its temperature minus its zero temperature. And then minus the mass of the water, which is also the mass of the ice, times the heat capacity of ice times 0 minus its temperature. And if we plug everything in, well, first we can pull out the mass of the water. So we get minus the mass of the water times quantity latent heat of fusion plus the heat capacity of water times the temperature of the water minus the heat capacity of ice times the temperature of the ice. And if we start plugging in numbers, we get that is minus 808 kilojoules. Now, we also know that there's no work done by the water or on the water, so the heat absorbed from the water is its change in internal energy, so that is minus 808 kilojoules. Now we know the performance, the coefficient of performance is the absolute value of the heat absorbed from the water divided by the work in. So we can find that the work in is the heat absorbed from the water, the absolute value of that, divided by the coefficient of performance, which is 2.4, and we get 337 kilojoules. Now the heat absorbed, the heat dumped to the waste heat rejected to the room is then just the work in, the work that is done minus the heat absorbed by the ice, and that winds up being 1,145 kilojoules.